Welcome to the ESTCP series on lighting technology transfer. This module on the fundamentals of lighting control systems is one in a series of 16 modules on advanced lighting controls. This module covers the fundamentals of lighting controls. Here we will look at why, as designers, managers, and users, we are interested in lighting controls. We'll cover traditional lighting controls, barriers to the adoption of new lighting controls, advanced lighting controls, and finally, controls strategies. Why are we interested in lighting controls, and specifically advanced lighting controls? According to the Energy Information Administration, its Commercial Buildings Energy Consumption Survey, lighting accounted for 17% of electricity use in its 2018 survey. It's likely that at some time, fluorescent lighting will not be available. Your building will move from fluorescent lighting to LEDs. If there's a one-to-one switch made from fluorescent bulbs to LEDs, surveys have shown there's often occupant dissatisfaction. This dissatisfaction is usually due to glare or overlit spaces, as the new LEDs often produce more lumens per watt than the replaced lighting. Use of advanced lighting controls can alleviate some of that dissatisfaction with the increased glare and lack of control from a one-to-one change. Moving to advanced lighting controls will lead to energy savings. Studies from the Lawrence Berkeley National Lab show savings of 24 to 38% from implementing various advanced lighting control strategies. And as facilities become concerned with resiliency, advanced lighting controls allow lighting to run longer during critical periods. Moving to advanced lighting controls also can provide the opportunity to integrate with other building controls and the potential to operate in the smart buildings arena. Retrofitting lighting entails replacing the bulb and the fixture. Placing bulbs and fixtures at the same time garners greater capabilities, including dimming, occupancy, and daylight harvesting. The installation is optimal to the planned design of LEDs, so the energy savings are greater than with bulb-only replacement. The upfront cost, however, is higher than bulb-only replacement. After a brief look at the basics of LEDs, we touch on lighting controls. Lighting controls manage the operation and output of the lighting. In traditional controls, most of us are familiar with standalone controls and relay panels. Standalone controls include items such as occupancy sensors, seen here, switches, and sensors. Some of the advantages of standalone controls are that there is no controls wiring and wireless connectivity is not necessary. Thus, it's easier and less costly. For installation purposes, wiring is familiar for installers. That the energy savings are smaller, and settings and strategies are only on the device and thus not centralized on traditional lighting controls. You likely have knowledge of low voltage relay panels. These panels consist of relays in a subpanel, which is connected to the main source panel. The relays operate the lighting fixtures based on schedules and occupancy and photo sensors. Schedules allow one to program times when the lighting comes on or off, such as on at 6 a.m., off at 6 p.m., off on weekdays, and so forth. The plus side of having traditional low-voltage relay panels is there is central control and programming for lighting. More strategies are available with relays than for standalone controls. The negatives are that the relay panels need to be wired separately from the main panel. Individual fixtures are addressable, but this is not easily accomplished. Control strategies are limited due to the limited sensors. Advanced lighting controls can simplify controlling your lighting and lead to additional energy savings. However, owners and facility managers have been slow to adopt advanced lighting controls. This may not be in the wheelhouse of installers not open to the new technology. With advanced lighting controls, standardization, especially of software and communications, can be lacking. Most advanced lighting control manufacturers have their own proprietary software and communications packages. Advanced lighting controls consist of one or a combination of fixture integrated sensors, which are also known as embedded sensors. These sensors are mounted or intrinsic to the fixture, room controllers for controls of a room, and networked systems, which are operated from a computer source. Standalone fixture integrated sensors, also known as embedded sensors, are built into the fixture, providing controls for the lamps in that fixture. While the fixture integrated sensor may be aftermarket, they are usually installed at the factory. There is no controls wiring here. The sensor controls only the lamp mounted in that fixture. This sensor controls only the associated lamp, and thus it is more specified or granular in its controls versus controlling a zone or number of lamps. This is less expensive than networked systems, as there is no controls wiring or wireless communications necessary to operate the control of that individual lamp. The fixture is wired to the AC source and it's ready to go. As a result, the controls can be reprogrammed if there is a change in space utilization or configuration. Drawbacks to standalone are that they are missing functions such as scheduling and demand response. There is limited collection of data as there is no networking and no communication. And a potential time consumer is the necessity to program the sensors independently. Need-based controls require pre-planning as there are a predetermined number of relays, dimming controls, and sensors. Controllers are easily installed in small rooms or small spaces. Changing the lighting zones, however, requires redoing the wiring to the fixtures, as the zoning is dependent on the switch legs of that circuit. Network control systems make for a large number of lighting possibilities. All of the sensing devices in lighting are connected, creating the opportunity for more capabilities. Simplified networked systems are wireless systems with integrated sensors and wired systems where the sensors are not integrated. The other networked systems are server-based systems, which are known as comprehensive networked systems. The pros of wireless controls is, of course, no wiring is required. This can be especially beneficial for renovations. Compatibility is often no issue as the sensors and controllers are factory installed. The systems are easy to install. Commissioning and programming can be done with smartphone or remote control. On the downside, being wireless, the controls may be frowned upon by the information technology department. With programming and setup done by the smartphone, who becomes responsible for providing the phone, the access to the app, and other potential telecommunication issues? Pros of wired controls are faster and more reliable network response. The drawbacks are low voltage wiring must be run from devices and sensors back to the fixtures. This is not ideal for renovation work. Locating sensors requires careful planning to get the desired results. Basic controls, which may be wired or wireless, are the most comprehensive type of advanced controls. These systems are tied to a computer or server. Strategies are many, with the possibilities available through the server. Communication with other control systems is also possible, including HVAC, window treatments, and so forth, which are available with advanced lighting controls, or task tuning or high-end trim, where light levels can be adjusted to the work in that space. Daylight harvesting, where light levels adjust based on daylight being sensed in an area. Occupancy, where lights will go on or off based on whether bodies are sensed in that space. Scheduling, where lighting can be adjusted to schedules of room occupants. And load shedding, where lights are programmed to participate in demand response with the local utility. In this module, we have seen that lighting is the second highest category use of electricity in the U.S. Lighting controls, especially advanced lighting controls, can reduce the electrical usage of lighting. Traditional lighting controls save less electricity than advanced lighting controls. However, building owners and operators are slow to adopt advanced lighting controls, mostly due to past experiences with advanced controls, lack of familiarity, and lack of standardization between manufacturers. Thank you for listening to this module on advanced lighting controls. We look forward to you on future modules.